Hi, I'm Troy McClure and welcome to my video. So today we're going to be working on the product rule proof. I had to double check then. So this is like, I did a proof on my last video. I can't remember. I think it was the power differentiation like rule. The one that, when you differentiate, you take the power and bring it to the front and minus a power. This one, I feel like is quite easy. We don't really have to. A lot of it is just kind of rearranging. It's quite easy. We use like first principles, and then beyond that, it's quite easy. I wrote everything out. I actually had to correct it. I made a slight mistake the first time, but I've written everything out. I've gone through it. I've checked it. So I'll just go through my working with you. I'll show you the steps. I don't know if it looks confusing. It's really simple. Like I think it's one of the easier proofs at this level. From I guess what I've seen. Not that I've seen a lot. Anyway, kind of rambling. Let's get into the proof and how we do it. So starting with z of x is equal to f of x times g of x. That's just what we're stating. So we're going to let z of x equal, I guess our function z of x is going to equal one function times another function. In this case, I've done z of x is equal to f of x times g of x. And in hindsight, I realized g's and f's look very similar. So I apologize if it's not readable. But that's what we're going to do. From there, we're going to use first principles. I think it's like, you can also call it derivative through, there's another word for it, but I like to call it first principles. Maybe I'll ping up the other words as well. But we're going to use first principles, and that is, I'm going to pop that up now. And I think it's basically like, as the limit of h goes to 0, f dash of x is equal to f of x plus h minus f of x over h. And that's it really. So you can just sub it into that principle, or I guess equation, whatever you want to call it. And then from there, when we get our z dash of x, it's going to be equal to f of x plus h times g of x plus h minus f of x times g of x over h. So all we've done is we've defined a function, I guess. We've subbed it into first principles, okay? And that's probably about the hardest thing we have to do. The rest of it's quite easy. So from here, I don't know if you've noticed, but this part is here. This part is at the end, okay? You've got f of x plus h times g of x plus h on the left, and then you've got f of x times g of x on the right, okay? What have we got in the middle? All we've done is, I'm trying to think how to explain this. Like, let's say you took an equation and you added 7 and subtracted 7. It's still the same value, but we've just written it in a different way. So in this example, we've added minus f of x plus h times g of x plus f of x plus h times g of x, because that's going to lead us to, I guess, simplifying and making this proof. So I don't know who came up with that. I guess someone a lot smarter than me or whoever made the proof. So that's what we're doing. We're putting that in there. And then from there, we're going to separate it apart a bit. So what have we done? We've just rewritten it as the first part and the second part. So it was all over h anyway. So we've just got the first part, which is the original, I guess, part, f of x plus h times g of x plus h, minus half of the new part we've thrown in. So minus f of x plus h times g of x all over h. And then we've got f of x plus h times g of x minus f of x times g of x over h. So we just separated it out a little bit, okay? And this is all for the limit as h tends to 0. Now we're going to take out, do you call it a factor still if it's a function? I guess so, but we're going to take out terms for each part of this. So for the first part, the term we're going to take out is f of x plus h. I'll put that on the side. And then for the right-hand side, this part, we're going to take out g of x, okay? Nice and simple, just rewriting it. And then we're going to rewrite the whole thing as a limit of h tends to 0. So this is like still written the same way, but we're just doing it as, you know, separate parts. So a limit as h tends to 0 of f of x plus h, and so on and so forth. We've got a limit as h tends to 0 for, you know, each part, but these are still grouped times together, and so are these. So we haven't really done much. And the reason we've written it in this form is because if you look at first principles again, I'll pull it up on the screen. This is the form of first principles. So what does that mean? That means we can change or substitute this in for the appropriate g of x, or g dash of x or f dash of x. Now we're pretty much at the end. We need to take the limit as h tends to 0 of basically all of this, but it doesn't really matter because you've only got an h in the first part, and as h tends to 0, f of x plus h basically becomes f of x, and that's going to give us f of x times g dash of x plus f dash of x times g of x. And that is obviously from our z of x is equal to f of x times g of x. So we've shown that when it's differentiated, you know, you have this product rule. Hopefully that made sense. Hopefully it was clear. I feel like that was quite, I don't want to say an easy proof, but I feel like it's quite a nice one. But yeah, hopefully that made sense. Hopefully it was clear. I don't always do this like high level stuff. I do have a maths degree. I have a 2-1. So I'm trying to, thought I might get back into it, make some videos. But yeah, so if I made a mistake, feel free to let me know. Or if you feel like I could improve, just don't be annoying. Yeah, let me know if you need any help. I'll try my best. I'm not like a pro, but hopefully that made sense. Hopefully it was a bit clearer. And yeah, thanks for watching the video.